Hi, this is a video on the binomial theorem, something you might come across in an Algebra 2 class, or perhaps in a Calculus 3 class, or a pre-calculus class. Well, what is a binomial, you say? Well, a binomial is a polynomial with two terms. Well, what's a polynomial? Well, a polynomial means it's an expression with multiple terms. And a binomial is one of those that only has two terms. Well, let me just show you one. X plus y. There you have it. That's a binomial. There are two terms, an x and a y. So it has more than one term. It's a polynomial. And there are two of them. It's a binomial, like a bicycle, two wheels, right? So a binomial has two terms. Notice that 2x plus x is not a binomial because that's just 3x. Or 5 plus 8 is not a binomial because that's just 13. But 2x plus 5 would be a binomial, or 2x plus 5y would be a binomial. There just have to be two terms that can't be combined with each other. So the binomial theorem is a shortcut to evaluate a binomial in the form of x plus y raised to some power. Could be the 56th power, could be the 32nd power, could be the second power. Basically, we say raised to the nth power, and n is a stand-in for whatever it actually is, whether it be 5 or 500. Okay? Let's look for the patterns. I saw this in a pre-calc textbook, and I thought it was a nice way to introduce this. So let's look for the patterns. Now, in the lower ones, we don't really need a formula. I could figure it out. But, for example, anything raised to the 0th power is 1. So I didn't need a formula for that. I would have known it. Anything raised to the first power is itself. So x plus y. I didn't need help with that. Even raised to the second power, you remember FOIL, first, outside, inside, last? So that I could have gotten this without a formula. You square the first one, square the last one, and then the middle term is outside, inside. xy plus xy is 2xy. But once we go a little higher, then we're going to begin to need a little formula, I think, to help us out, unless we want to be writing an awful lot, especially if it's to the 156th power. That's going to be hard any way you look at it. But anyway, there are some powers. So in these cases, we have x squared on the front and y squared on the end, x cubed. Notice the powers match. So the first power and the last power are going to be the same as whatever power the binomial is raised to. Oh, that's easy. That's pretty nice. By the way, if it had been 2x plus y, then this would have been 4x squared. We'd have squared the 4. Or if it had been x plus 3y squared, then this would have been 9y squared. So it can get a little bit more complicated than just being the x squared and the y squared at the front of the n. But I'm seeing some patterns here. Notice in this one that the second coefficient, the coefficient is of course the number on the front, and the second to last coefficient are the same. Same thing here. The second coefficient and the second to last coefficient are the same. Well, that's going to be fairly typical as well as we go through this. Anyway, so let's just get some patterns down here. The total number of terms is going to be one more than whatever the power is. So in this one, the power was 0. 0 plus 1 is 1, so there was one term here. The power here is 1. 1 plus 1 is 2, and there were, as you can see it, x plus y, there are two terms here. 2, and then there are 3 terms here. Third power, and there are 1, 2, 3, 4 powers here. Fourth power, 1, 2, 3, 4, 5 powers there. So there's always one more term when you play it out than there is power that it's raised to. Another thing you might notice is that the powers in each one add up to the total power of the binomial. So look at this one. This is to the 4th power. The first one is to the 4th power. The second one, anything when we don't write, that's to the first power there. So 3 plus 1 is 4. 2 plus 2 is 4. 1 plus 3 is 4, and 4. So the terms, the powers in each expression add up to the power of the binomial. So 3, 2 plus 1 is 3, 1 plus 2 is 3, 3. Second power, 1 plus 1 is 2, second power, 1, first power, and so forth. So the powers in each term are going to add up to the power of the binomial. Then notice that the x goes down and the y goes up. So just notice here we have 2x squared, x1, no x. x3, x2, x1, no x. x4, x3, x2, x1, no x. And by contrast, no y, 1y, y to the second. No y, y to the first, y to the second, y to the third. No y, y to the first, y to the second, y to the third, y to the fourth. So you see these powers. There's some powers here. There's another pattern. There's a guy named Pascal. Blaise Pascal is a very clever beast. Must have had too much time on his hands. But he came up with something called Pascal's triangle. What you'll notice is each term is the sum of the two terms above it. So 1 plus 0 is 1. And then 1 plus 0 is 1. 1 plus 0 is 1. 1 plus 1 is 2. 1 plus 0 is 1. Let's go down here. 1 plus 0 is 1. 1 plus 2 is 3. 2 plus 1 is 3. 1 plus 0 is 1. Then here, 1 plus 0 is 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. 1 plus 0 is 1. You're wondering, where have we gone? Why are we looking at this? Well, if you have a perfect memory, you might notice that, for example, take the fifth line here. 1, 4, 6, 4, 1. Now look at this here. 1, 4, 6, 4, 1. Wow. For something raised to the fourth power, the coefficients are exactly as for something raised to the fourth power, the coefficients are the same as the fifth line of Pascal's triangle. Let's try the fourth line of Pascal's triangle. 1, 3, 3, 1 and 1, 3, 3, 1. So something raised to the third power is going to have the same coefficients as the fourth line of Pascal's triangle. Let's try one last time. 1, 2, 1. 1, 2, 1. Okay, that works. So if you have an infinite amount of time on your hands, you can just keep playing out Pascal's triangle, and you can know what all the coefficients are to something raised to the 52nd power. That still might be a little bit long to do, especially when calculators figure out some of these things. There is a more technical way to figure out the coefficients. So say we have a scary term, a to the ax to the n minus r times y to the r. This is, say, one of say there's 5 terms, and this is one of them. So a here represents the coefficient that we were just looking at. You can find it using Pascal's triangle. N is the power of the thing. So remember that 4, 3, this is the power of the thing right here. The r, what is the r? The r is basically where the number of the coefficient. But here's a secret here. The first one is counted as 0. So it goes 0, 1, 2, 3, 4. So if you wanted to find the coefficient on this term, you would set it as r equals 1. And if you wanted to find the coefficient on this one, you would set it as r equals 2. And if you wanted to find the coefficient on this one, r equals 3 and r equals 4. So that's a little tricky. But basically, so let's say you want to find a term that is coefficient x to the power it's raised minus the term starting with 0, and then y to the term starting with 0. We can plug it into this formula. Man, Pascal's triangle is looking pretty nice here, but let's learn it. So this exclamation mark means factorial. A factorial, 4 factorial, for example, means 4 times 3 times 2 times 1. So the coefficient of the, say, the second term, if we start with 0, we have 0, 1, so r is going to equal 1 for the second term. And so let's say we want to figure out the coefficient. Let's say we want to figure out the third coefficient. We already know it's 6. But let's say we want to figure out the third coefficient where n equals 4 and r equals 0, 1, 2. So r equals 2. So n equals 4, r equals 2. Let's plug it in, baby. These are a couple other ways to write it. N choose r, and then out of n total elements, choose r of them. Anyway, don't worry about that. So let's do this. Remember, we were going to the fourth power, and we were looking for the third term, which is r equals 2. So let's plug it in. So n equals 4, and r, since it's the third term, and we start with 0, 0, 1, 2, we're going to put in a 2. So 4 factorial is 4 times 3 times 2 times 1. And then n minus r is 4 minus 2. R is 2. So let's play it out. By the way, you can cancel. You know, these 2 over 2 cancels out. Sometimes it's nice to cancel out. But basically, so I canceled out the 2's there. 4 times 3 over 2 is 12 divided by 2 equals 6. And remember, that's what it was. It was 6. If I go back, you'll see that the third term, r equals 2, is a 6. Happy days. So that's the binomial theorem. And I've been putting off, putting the full name of it, but there's the full shebang right here. So if I want to know x plus y to the n, the first one is going to be x to the n, and the last one's going to be y to the n. It doesn't have to be an x and a y, by the way. Whatever's in these slots, there's going to be 1 to the n, and on the other end, the other one to the n. And then the second one, remember the second one, I don't think I told you this. Let's go back, and another observation I want to point out is that notice that the coefficient of the second number is always the same as the power. So there's a 2, and then the second one there's a 3, the second one there's a 4, and then I also told you that the second to last is going to be exactly the same. So when we get back to the big formula, the second one has the coefficient of the power, and the second to last one has the coefficient of the power. Then notice that the x's go down. X to the n minus 1, x to the n minus 2, x to the n minus r, where r is, if this is 0, r equals 0, then this is r equals 1, and so forth, until you get to just the x and then no x. And then the y's are going to go up. 1, 2, in the middle, it's going to be r, where r is the 0, 1, so y to the 1. And then y to the n minus 1 before you finally get to y to the n. Notice again that the powers are going to add up. So 1 plus n minus 1 is going to be n. And n minus r plus r is n. All of these are going to add up to n. N minus 1 times 1, or plus 1 is n. So all of them, remember, go back a couple slides, all of the powers of these add up to the same power as n. This is the coefficient is the tricky one, figuring out the coefficients in the middle. If you don't have that many, then use Pascal's triangle. If you have 52, then use your calculator using this coefficient formula. Well, it's maybe not easy, but it's not as hard as it could be. There you have it, the binomial theorem.